Today we're going to get into lesson 4.4, which is over graphing linear equations in slope-intercept form. Slope-intercept form is a very important topic on how you graph linear equations. If you were one who struggled with 4.1 whenever we had to pick x values, plug them in, get y values, and graph lines that way, that's fine because this is a little simpler way to do that. And we'll talk about how we use slope-intercept form to graph linear equations. First, some key vocabulary. Obviously, you need to know what slope-intercept form is. It says it's a linear equation written in the form y equals mx plus b. That should be like something that never leaves your mind when it comes to 8th grade math. Y equals mx plus b. You'll use that a lot. Y equals mx plus b is a very important equation. The slope of the line is m, which we've discussed already. Remember, m represents slope. We haven't talked about b though. The y-intercept of a line is b. So y-intercept of a line means when the line goes through the y-axis, or it intercepts the y-axis. So that point is represented by b. So in this equation, y and x stay there. M is your slope, b is your y-intercept. Make sure you keep those straight. So it says, like I already mentioned for a second, the y-intercept is the y-coordinate of the point where a line crosses the y-axis. Okay, that's used quite often. The y-intercept is used a lot. So it's where that y-coordinate of the point where a line crosses that y-axis that's running vertically. X-intercept you don't use as much, but it is still important to know. That's the x-coordinate of the point where the line crosses the x-axis. So obviously wherever that line, the line that you draw crosses that side-to-side axis, which is your x-axis, that is your x-intercept. Main things that we'll touch on are these top two though. So slope-intercept form, definitely need to know y equals mx plus b, and your y-intercept is where that line crosses through your y-axis. So first they might ask, we want to make sure we can identify or pick out our slope and y-intercept. So it says find the slope and y-intercept of the graph of the linear equation. Okay, so they give us this equation right here, and they want us to pick out what the slope is, or what the slope is and what the y-intercept is. So again, your form that you're looking at is y equals mx plus b. So remember, m is your slope, b is your y-intercept. So in this first bullet, my slope, my m, would equal what's in that m position, which is -4. So m equals -4. Again, this is a very straightforward example, but you do need to be able to identify so that you can use them. So then that means my b is what is in this b position. So this is plus b, so since this is now minus b, remember this is minus sign can act as a negative as well. So this is really, my b in this problem will be -2. So what that means is this line crosses through that y-axis or intercepts that y-axis at the point -2. And this line has a slope of -4. So then the second one, if you look, this one's not quite in, because again, we're looking at the form of slope-intercept form, y equals mx plus b. In this form, y is by itself. If you look in this one, y is not by itself yet. So let me bring that equation over here. We have y minus 5 equals 3/2 x. If this is not in slope-intercept form yet, you need to get it to slope-intercept form by getting y by itself. So in order to do that, we have to move the -5. So going back to chapter 1, we do the opposite, which is +5. When we do that, that cancels with that. Y equals, and remember, this has an x, this does not, so those cannot combine. So you just bring it down as is. 3/2 x, then +5. Now we can identify our slope and y-intercept because it's in slope-intercept form. So if we look, my slope is my m. 3/2 is in that m position. So my slope in this problem is 3/2. And that means my b, or my y-intercept, is in the B position, that would be 5 in this problem. Okay, so we have to identify them and be able to pick them out before we even use them, and we'll talk about how we actually use that to graph as well. So, using that idea, I want you to try this one on your own. Find the slope and y-intercept of those, and then we'll talk about solving that together. So hopefully you pause the video and try this out. Again, this first one, you can check and ask yourself, is it already in slope-intercept form? And this one luckily is. It is in slope-intercept form in y equals mx plus b. So then we just pick out our m and pick out our b. My m in this case is 3. So that's my slope. My b in this case, again, make sure if this is minus, that goes with it. So this is a -7 for my b. -7 is my y-intercept. Okay, so that's the first one. The second one, again, you'll look, this is not in slope-intercept form yet, so you need to get it to slope-intercept form before you choose what your slope and your y-intercept are. So in order to get y by itself, we add 1 to both sides. Y equals, remember, this does not become -4 because -5x cannot combine with +1. They both have to either have a variable or both cannot have a variable in order to combine. So since one has a variable, one does not, they are not like terms, so you bring it down as is, -5x plus 1. Now we just choose or identify my slope and y-intercept. So slope in this case would be -5 and y-intercept would be 1. Alright, so make sure you can identify and pick out your y-intercept and slope because that's important to now use to actually graph these linear equations. So this is the directions on how you're going to graph these linear equations. So it says to graph linear equations in slope-intercept form, you will make your first point by using your y-intercept, your b. Okay, so what that means is you're going to choose, like, whatever your y-intercept is in your slope-intercept form, you're going to go to the y-axis and make a point at that intercept on that y-axis. That's where your first point would be. And then from that point, you'll make a second point using your slope. So think back to the last section we talked about. What is the words that go with slope when talking about a graph? If you remember, it's rise over run. So what you're going to do is use that slope, rise over run, to go from that first point, and you're going to rise however many and run however many to get to your next point. Okay, and this will make a little more sense as we look at an example. So, but that is the main idea of what we're going to be doing with this. So let's look at a couple examples. I'm going to have you write those down because then we're going to move over to the coordinate plane to graph these. So make sure you write those down, and then we'll move over here so that we can graph these properly. Alright, so I'm going to go ahead and move the camera over to the coordinate plane. Okay, so the first one was y equals -3x plus 3. So y equals, right over here, y equals -3x plus 3. So again, the first point that you make is from your y-intercept. And in this case, my y-intercept, my b, is 3. So 3 is what the y-intercept of this problem is 3. And what that means is, on the y-axis, which is right here, running vertically, the point 3 is where my line is going to go through the y-axis. So that's where my first point's going to be. So on the y-axis, I go up to 3 and make my first point. That is where my first point will be when graphing in slope-intercept form. From there, you have to use your slope, which in this case, m equals -3. You have to use that to make another point. And let me show you what that's going to look like. First of all, we need this slope in rise over run form. As you can see, this is a whole number. So anytime you have a whole number, you can just make that a fraction by putting a 1 underneath it. So my rise over run in this case is -3 is my rise, my run is 1. So from this point that I made, I'm going to rise -3 and run 1. So what that will look like, if it's -3, remember rise means I'm going up or down. If it's positive, I go up. If it's negative, I go down. So if it's -3, that means from this point, I'm going to go down 1, 2, 3. And that's where I'm at so far. And then I stay there, and then I look at my run, which is 1. If my run is positive, that means I go right 1. So from here, I go right 1. And once I've done my rise over run, that is where I make my next point. So that is my other point. And that's it. That's all you have to do for slope-intercept form. Because then once you have your two points, you can draw your line through them. And this is what your line will look like by doing it in slope-intercept form. Okay, by graphing in slope-intercept form. And if you were to do like we did in section 1, where you pick x values, plug in, solve, get your y with that table, you'll also get the line like this. But obviously slope-intercept form is a little quicker if you know how to use it correctly. So let's look at another example. We have that second one is y plus 6. Y plus 6 equals 2x. So as you can see, this is not in slope-intercept form yet. So you need to get it to slope-intercept form before you graph it or start to graph it. So in order to do that, we got to get y by itself. We subtract 6 from both sides. It'll be y equals 2x minus 6, because you can't combine 2x and -6. So you just bring it down as is because they're not like terms. Now this is in slope-intercept form, so I can begin to graph it. So again, first point comes from my y-intercept. In this problem, my y-intercept is -6. Again, that minus sign goes with it. If you make your y-intercept +6, that is incorrect. So my b in this case is -6. So that means on the y-axis, I go to -6, and that is where my first point will be. Okay, so from there, once I've made my first point, I then use my slope, which in this case is 2, to make another point. Again, you want it in rise over run form, so I'm going to change that 2 to 2 over 1. So what that means is I'm going to rise 2 and run 1 from this point. So rise 2, +2 means I go up, 1, 2 spots. +1 on the bottom means I run 1 to the right, 1, and that is where your next point will be. And if you want to make another point, you can do that again. You can do 2 over 1 again from this point. Up 2 over 1, make another point. And you can keep doing that as long as you want. It's going to keep giving you that on that same line. Up 2, right 1. Again, you only need 2, but you can do as many as you want to make that line extended. So then I just connect my points that I've made. And there is my line for this linear equation. So the linear equation, y equals 2x minus 6, is represented by that graph. Okay, so I'm going to go over here. We're going to try and do a couple on your own. Okay, so I'll just carry the phone over so you can write these down. Then we'll move back over to the coordinate plane. Okay, so take a second, write those down. We're going to graph y equals 2x minus 5 and graph y minus 4 equals -3x. So once you've written those down, we'll move back over here. And we're going to graph those on the coordinate plane. And I know it's hard to see, like the math on the coordinate plane. Hopefully you're just listening and you can hear it as well as I write it down. That first one was y equals 2x minus 5. And again, hopefully you pause the video and try this on your own first. But again, first you check if that's in slope-intercept form. Yes, it is. So since it is in slope-intercept form, we can go ahead and graph by choosing or locating our b or our y-intercept first, because that's where our first point comes from. In this problem, b equals -5. b equals -5 because that's in the b slot. And again, the negative sign goes with it, or the minus sign. So that means on the y-axis, that's my y-intercept. So I go to -5, make a point. Then I look at my slope. My slope in this case is 2. M equals 2. So you want that in rise over run form. So it'd be 2 over 1. 2 over 1 means from this point I rise 2, 1, 2, run 1, run 1, like that. And I can do it again, up 2, run 1. And from there, I'm going to connect or draw a line through these points. And there's your graph for this one, 2x minus 5. So 2x minus 5 is represented by that line. So let's look at the next one. We have y minus 4. Y minus 4 equals -3x. So as you can see, this is not in slope-intercept form yet, so you need to get it to slope-intercept form first. So to do that, we add 4 to both sides in order to get y by itself. It'll be y equals, those can't combine because one has a variable, one does not. They're not like terms. Y equals -3x plus 4. Now we locate our slope and y-intercept. Again, y-intercept is used first because that's where our first point comes from, which in this case is 4. So b equals 4. So I go to my y-axis, go up to 4. There's my first point at 4 on the y-axis. Then we have to use our slope, which in this case m equals -3. You want that in slope-intercept form. Again, sometimes they'll give you fractions of slopes, then you don't have to change it to rise over run. If they give you whole numbers, you do want to put a 1 under it to make sure it's rise over run. So my slope is -3 over 1. So from this point, I rise -3, meaning I go down -3, 1, 2, 3, and run +1. Run 1, like that, to the right. And I can do that again. Down 1, 2, 3, run 1 to the right. And those are my points for this line. And I connect it or draw the line through it. There is your graph for this one. One thing I do want to mention, because I don't include an example of it in this, but I know you will probably see it. If you are given a slope of like y equals -3 over 2 x plus 1, something like that. So I'm just going to go through this quick because I want to explain something. But so your negative or your +1 is your y-intercept, which is right there. But if you have a negative fraction, that just means that one of the numbers, and usually you can just do the top number, would be negative. It doesn't mean they're both negative. Okay, so for this example, you would go from here down 3 because that's your rise. The negative sign can go with it. Down 3, 1, 2, 3, and then this is still positive, so it can go right 2, and that's where your next point would be. Okay, so if you move negative with one, if the fraction is negative, you move negative with one of the directions, but not with the other. Okay, because this makes sense because then when you draw the line through it, just by looking at it, you can tell it has a negative slope. which this does have a negative slope, so that would make sense. So just a quick heads up, if you have a negative fraction, that's what that would look like. All right, let's look at one more. I'm going to take it back over to the screen because this is more of a real life example. Okay, so take a second to write that down. It says the cost in dollars of taking a taxi X miles is Y equals 2.5X plus 2. Graph the equation, interpret the Y, intercept, and slope. Okay, so I'm just going to make a quick coordinate plane right here, just so I don't have to keep moving back and forth. Okay, so first thing it wants us to do is graph it, which we can graph these. We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. And same thing at the bottom. So if I'm graphing this, I have to use my y-intercept first. So my y-intercept is 2, meaning I go up to 2, and that's where I make my first point. Then the slope is 2.5. So what that means is I need to take 2.5 and put it over 1, and that can be my rise over run. So from here, I'm going to rise 2.5, 1, 2, and then another half, which would be about right here, and then run 1, which would be about right there. Okay? And I know obviously whenever you make your own coordinate planes, it's not perfect, but understanding the idea is more important than that. So right here, I'll connect these lines, and this will be my graph for this. The interpreting part is more of a deeper thinking question because you have to think about the example that they gave you or the context of the problem. So first of all, we want to know what the y-intercept and slope means. The slope is usually easier to understand. It says the cost in dollars of taking a taxi X miles. So we know that X represents the miles you are taking. Okay, so the miles that you're going. So if you're multiplying the miles you're taking by a number, what do you think that would mean? Okay, and again, take a second, try and deep think about what that would mean. But what that means is 2.5 means you're paying 2.5 or $2.50 for every mile you take. Okay, so every mile you go, you're paying $2.50. So that would be how you would interpret the slope. To interpret the y-intercept, we're also adding on 2. So if you're adding on 2, why would you add on 2? Again, take a second to think. But what that 2 could be would be just the initial fee, meaning before you go anywhere, you have to pay $2. Okay, so that's why they add on $2 because it's not included in the per mile cost. It's added on because that is how much you're charged just to take the taxi. Okay, so that's a little bit, like I said, that's your deeper thinking a little bit, but that's how you would interpret your y-intercept and slope. So that's it for this section. Hopefully you understood slope-intercept form. Like I said, the main points with that is you need to know y equals mx plus b. That's very important. Slope-intercept form is y equals mx plus b. Your m is your slope. Your b is your y-intercept. When you graph these equations, you have to know that the first step is to graph the y-intercept, meaning you go on the y-axis to that point, make a point, and then from that point, use your slope, or rise over run, to go up and over to however many places to get to your next point, and then that's how you graph these equations. Thanks.